our technology partner, Omron, as our speaker today. Thank you for attending day 2 of Kepware Quick Knowledge webinar. This is organized by Kepware Allied Solutions, and Allied Solutions is the master distributor of Kepware in this region. And today we are also very happy to have our technology partner Omron as our speaker today. So our day 2 agenda, this is our day 2 agenda. We will have a brief opening for attendees who have missed day 1, just a brief one. Then we will move on to talk about Kepware Edge and implementing IoT solutions with Kepware. There will also be demonstration on Kepware Edge and also the Kepware to Azure IoT. To end the session, we will have Omron to talk about some ready solutions with Kepware. So just some brief information about Allied Solutions. Allied Solutions has been the master distributor of Kepware for the past more than 20 years. Our headquarters is in Singapore and we have offices around the region. We are focused in areas of our focus are into automation system, industrial and manufacturing software, industrial cybersecurity, fault tolerance and high availability platform for the for different manufacturing software, and also we do industrial networking products as well. Our solution and services is being deployed in all types of industry. We have a wide spectrum of domain knowledge to provide our customer with the right products and solution. Now let's move on to Kepware. Kepware was established in 1995 and currently I think it's the top company in industrial connectivity platform. Kepware EX server, Kepware server EX is Kepware's flagship product, and you can see from the diagram, Kepware offers a library of 150 plus device driver, client drivers, and advanced plugin for connectivity to top PLC vendors in the market. And we also have drivers for certain industrial initiatives like MT Connect, DNP3, IEC 61580, 60870, and or for more into the building site BugNet. It also provides access to client applications like the ERP, MES, HMI, and SCADA via OPC and provide proprietary protocols, as well as new breed of IoT visualization and analysis product via MQTT, REST, and other IT-centric protocols. And finally, Kepware is tested by independent agency, industrial automation users, and internal stakeholder, both to ensure the highest standard of quality throughout third-party validation. This is a very good diagram to illustrate and to give you an overall picture of what Kepware does. So you can see in the middle, we have the Kep server EX in the center. And typically in the plant floor, you have PLCs, barcode check weigher, RFID that we connect to, or on the building site we have a chiller that we use BugNet protocol, or in the certain oil and gas industry we have different type of flow meters out there. And we also link it to different network products via SNMP protocol. So we can be able to bring in all the different data from different equipments and different instruments from the plant. and bring up the data to software in the plant, such as SCADA software, manufacturing execution software, ERP software, or the plant ODBC compliance database. Or we could bring it to a big data platform via REST or MQTT, or we also have dedicated drivers, especially for big data platform like Splunk and ThingWorx. Yesterday, we also touched a lot onto the OPC UA tunneling to a remote site using Kepware. So in summary, companies normally need to overcome a server communication challenge present in the environment using many brands of different driver in order to gain access to the industrial data. But now with the use of Kepware, you can use it as a single platform. We just need a single Kep Server EX single platform for collecting, aggregating, and providing secure access to all the plant data. So you could download the software, the Kepware, all the Kepware drivers are able to be downloaded from the Kepware website. Once you download, you have 2 hours access, and then we can restart it and continue to try it. If you need longer than that, you can always contact us at the email below, or just give us a call, and we can arrange a 30 days trial license for your testing. So feel free to try out and let us know. Okay, with that, I will pass on to our next speaker, Steve from Kepware, to touch on the Kepware Edge. Thank you, Steve.
Hello, hello. Can you all hear me?
Yes.
Can. Okay.
Yeah, we can hear you. Yeah.
Hello. Hi, I'm Steve. I am the senior application engineer with Kepware. So I think some of you may know me, some of you may not know me, but it's okay. Anyway, just to to orientate everybody a bit. If you have any questions, is similar to what we go through yesterday. Just type into the Q&A panel. Try not to type into the chat box, because if you type in the chat box, we don't really man that one. So try to put it to the Q&A. So for today, I'm going to just talk about the ThingWorx Kepware Edge, which is a pretty new product that we have. So before we go into the product, let's talk about like some of the key challenges today that system integrator are facing, especially when working with machine builders. Right. So the first problem, or rather the first challenge that they have, is the increasing demand for digital. Right. Everybody's trying to do the digital digitizations, or actually trying to do something related to that. And for that to happen, there is a very big demand for connected machine. Right. In order to have the machines connected, and it has to be connected to enterprise systems, so that can interoperate and IT can manage them and things like that. It has to be manageable, patchable, and things like that. So that's really one of the key challenges for connectivity needs in terms of the first step to get into the digital era. The next thing that I think most of the machine makers want right today is really to have a demand for smart machines, right? Once you get it connected, you want to have some sort of closed loop feedback system in order to do, to leverage not emerging technology, but analytics and alarming, for the machines to act upon something, right? When an event happens, you want that something on the back end to power that and provide the analytics, and then make an informed decision to actually do something. So with that, there is a new level of destination that machine builders need to interface with. So these are typically the more IT-centric systems, and also, as opposed to the more traditional OT environment, a lot of the protocols, like Ching Pei mentioned, the MQTT stuff and REST are still fairly new to most of the control systems engineers, right? So that is something new for the machine builders, and they need to push the product to the market in a relatively fast pace to catch up with the emerging trend. So they need something out of the box that is easy to do. And on top of that, the connectivity to the traditional OT system is still required. And typically in OT, we want something that is proven, something that people have used before. You're not like the new GDP or anything. So that's really one of the challenges that the system integrators are facing when dealing with the kind of project that they are seeing. Last but not least, the lack of talent pool, right? Like connectivity is actually pretty niche, right? And in order to do it right, you require certain domain knowledge into certain areas of the IoT segment in order to do the connectivity right. So really there's a challenge in the sense that if a machine builder today wants to do a DIY solution, it could be pretty challenging because you need to find people who can do networking, can code libraries, drivers, and still understand OT and also understand cloud, things like that. So it's a pretty big hurdle, right? And on top of that, if they choose to go to the DIY track, right, it will have typically we identify already, we interview and we found out there's 4 of the common themes that resonate well with the people that we interview. So the first one is the speed of implementation, right? How fast can they go to market with a DIY connectivity? You may be doing something like a Modbus driver today, but then when you go to another customer, they ask for something else, and then you have to go through the whole cycle again and again. So that's something that they need to consider, right? The next thing will be ongoing maintenance, right? A lot of times once the codes are out, as they say that there's no bug-free software out there, there's always a bug to fix. So that's something that they need to consider as well. So the support and post-sale support is something that they need to consider and build around in order to deliver that kind of solution. Then, as I mentioned, the evolving requirement. So there's like in OT is pretty non-homogeneous. So it's pretty much like you have thousands of different brands, thousands of devices to connect to. So each of them may have different requirement, right? So does it make sense for the DIY solution to keep coding and keep building against some devices or even a specific device for a certain action, right? Then, of course, the most important thing I would say that in at least in IoT connectivity would be your security, right? How secure are your codes, right? Are they pen tested? Are they tested against something? Is there a certain practice in place? Are there CVE being reviewed, your vulnerabilities, all these things. So that's security. So as I talk about the speed of implementation, right? If you look at the top chart, that's pretty much a typical software development cycle. So you can see that we typically are looking at months or days into it. So we are typically looking at months and years, and pretty much you start with a definition, right? The scope of work. You size up what you want to do, and in a certain development cycle, you have to do sprints, right? Sprinting, and then you test and deploy. So that's pretty much a very typical software engineering cycle, right? So if let's say there is a product out there that allows you to quickly download and try it out, and then all you have to do is just licensing and deploy. So that will save you a ton of man days, right? Which translates to cost saving for a lot of the machine builders, right? Then we talk about ongoing maintenance, right? In order to, once you finish with the software cycle, you pretty much have to do maintenance. If there are issues, especially in OT, right? We are dealing with machines, and those machines could be something that are operational critical, right? So that's something that they need to consider and have some form of active support. So compared to a DIY solution, if you take something that's out of the box, all you have to do, is to offset that load into the product itself. And ideally, this product will do continuous improvement and upgrade and provide you patches, upgrade consistently. Next, we talk about security and reliability. So whichever sector the machine builder is in, and if they are doing IoT stuff, pretty much security should be the foundation or the first thing they think about. And the problem with that is that in manufacturing, there's a lot of different sectors. So again, the DIY solution has to consider whether their solution complies to certain requirement from the different sectors. Right? So that's another development effort, and that brings additional cost to the machine builder as well. So the goal of the TKE, which is the ThinkWorks CapWare Edge, is actually to deliver connectivity to legacy enterprise, analytics, and industrial IoT without creating custom code. So the idea is to kind of have a specific build of CapWare, right? The CapWare that I think most of you are using in the Windows environment, but we want something that was designed and fits well into the machine builder market. So if you're a machine builder today, thank you for attending this session. You can take a look and consider what you can do with the TKE. So the value of the product itself is firstly to eliminate the need to create the custom code, right? So you don't have to have a huge team of developers to do code testing, code development, but rather you just need someone who is trained in using the TKE, and they could quickly get the connectivity portion up, right? It accelerates it. And because of that, right, the product itself is pretty special compared to the traditional CAP Server EX, in the sense that this product itself is designed to be programmatically configured. And the key reason being that once the machine is being deployed, right, typically you don't have the luxury of going down to the site and and program it on the spot. So we have a way to programmatically call it via REST calls to configure it, or if you need to do anything on the fly, you can actually do like scripted scripts to actually configure it and deploy out. And the product itself, right, delivers differentiated machine connectivity. So it has the traditional OT requirement as well as the enterprise and cloud analytics and IoT integration requirement. So that's the idea of the TKE, right? We'll talk more about that on how far we are on that. Last but not least, it eliminates because being a commercial out of the shelf solution, right? It means that you don't really have to do the hiring or talent crunch, or you don't deal with all that. You offset that to kind of offset that with CapWare, and and get the same level of support that you get from the Windows version of CapWare. So in line with what we talk about for continuous patching and things like that, the product itself is a subscription-only product right now. So and the key reason being that is part of the business model that CapWare and PDC, we are committing to providing you the ongoing bug fixes, testing, and compliance and things like that. So the product itself will keep continuously being patched and tested against new models and things like that. And that's really the key reason why the product itself is a subscription-based. So out of the box, right, this is pretty much a summary of what we concluded based on the marketing research. So you can see it's just bullet points here. I won't talk too much about it, but the key thing is that the product itself is very similar to what you are using in the Windows version of CapWare. In fact, the underlying drivers and libraries are pretty much the same thing. So we are reusing it. So you can be assured that this is not something that is a brand new driver or anything. It's actually a cumulative experience of the Windows version of CapWare being brought over to the TKE. So these are a bunch of features that we have. Out of the box, it is headless, which means that there's no GUI, which I'll demonstrate a little bit on the demo later. The code base itself is the same code base used on the Windows version. So you're not a guinea pig. It's something that you can use, and you have used it before in the Windows version. For those who are using ThinkWorks, it has native integration to it, so you can connect to a ThinkWorks platform directly. At launch, right now we have only 3 drivers, which is the Allen Bradley Control Logics driver, which is Rockwell PLCs, and the Siemens S7 series, which is quite similar to Siemens Ethernet, and Modbus, right? Modbus TCP. And in terms of the northbound connectivity, we have the OPC UA, MQTT, and that's pretty much the 2 protocol that allows you to send out to most of the IT-centric software out there, right? So if you look at the diagram, we actually have on the southbound, we have the AB, Siemens, and Modbus. And then for that to happen, when you do the configuration, you're using a third-party RESTful client, so it's headless. And on top of that, when we send out the data, you can choose any of this. So it's designed to go interface with cloud solutions and I would say the emerging SCADA, which has OPC UA built in. Right. So this is the system specification. So you can see, you can read through, when we send out the PDF, nothing too fantastic here. Yeah. And in terms of roadmap, right now, today we are at here, 1.1. 1.2 is coming out soon. So our initial launch or the spec sheet that you saw just now was actually the 1.0. And you can see that this product was launched very recent. It's on October, right? October 2019. And in January, we actually have the 1.1 coming out. And in 1.2, which is coming soon, is the enhancement and the new drivers, as well as some UA enhancement. Right. So in terms of the future direction, you can see that our full intention is to slowly add on additional advanced capabilities to fit the requirement for the edge side of things. And our drivers that we are going to add on are the UA client, the backnet, and the Mitsubishi drivers. So those are coming. Yeah, so you can see that my presentation for this is pretty short. So I will go straight to a demo right now. So on the left side, you can see that I have a Ubuntu instance, right? So it's a Linux, kind of Linux solution. So I just want to go in quickly to show you what the interface looks like. Oops. So you can see that on the right side, I have the Postman. So this is pretty much how you will call and configure the device itself. So you can see that on the left side, the instance, this is entirely command driven. So you can actually like manage, you have to manage every single thing through command line, right? So whatever you see here is pretty much the same thing you will get from from reading off the manual. No, so you have to do an initialization configuration for ways to interface with the system. And once you have done that, pretty much you can start doing the REST calls. So as an example, right, you see, I'm going to do a quick call for to the TKE, and we will see what we have on the project side of things. So you can see that there is a project interface here, which is pretty much the JSON representation of the project node of the CAP server EX. So this is exactly similar to this. If you take the Windows version and you just do a right-click properties, right? Whatever you see here is actually compressed a JSON representation of the interface of this project menu. So you can see the stuff here is actually pretty similar, right? UA enable, diagnostics, allow anonymous login, things like that. Right, so this is pretty much the same thing, and what we really can do, right, is to establish a UA connection to the TKE, right? So I can show you that so what I'm going to do is I'm going to use the Windows version of the UA client driver, right? So you can see this is actually a UA client driver, right? And I set the UA server to the TKE, and then what we'll do is that we can actually use the browse function to take a look at the current project layout. So you can see that there is inside the project right now, there is a channel and there's a device. And this is, for those who are familiar, this is our simulation driver demo file, right? It has all the different samples of the simulator driver. So we'll just add it in, right? Just to show you guys. I'll remove the internal text. Okay. And then we have launched the quick client. So what we're doing now is that we are doing a UA client connection into the TKE right now, right? So I'm using the CAP server over here to connect into the TKE instance using OPC UA, right? So that's really what the connection connection looks like. And what we are going to do a demonstration right now is the way we can get some information and create a certain channel, right? So in fact, let's do the get channel call. So if I do a get channel call, basically if you follow the documentation, it's really just a call to the /channels, a get call, and then you do it. You can see the representation of the channels right now. So you can see that right now I have a channel called channel 1, and it is the simulator driver, right, which is really what we saw just now using the UA client. So what we're going to do now is we are going to create something instead. We're going to create a Modbus channel. Right, and the way to do it really is just to have JSON payload of your preferred name and at a very minimal the driver that you're using, right? And then you do a post to it, a post. So you can see that it says 1, that means actually it's done. So if we do a get channel again, you will see that now we have 2 channels. And that's really what we mean by programmatically accessing the TKE itself. So it's entirely, completely programmatically driven. And I actually left out one thing. So the key thing of why we are doing this on Linux is that because when we consider the edge, we see that in the future that probably is going to be on thin client. And typically what that means is it's going to be Linux based. So the plan is really just to go there. And having the Linux built version, right, it means that you can also save on OS costs, right? If you're not, you don't have to pay for like all the Windows licensing and things like that. So again, I'm going to just quickly do a same thing for the device. So for those who are not so familiar with Kepware, what we're doing right here is actually just doing the standard channel device tag creation, right? So you can see there's no device right now. And what I'm going to do is I'm going to just create one. Again, it's just a simple JSON, and you do a REST call to it. And pretty much if you do another get, oops, wrong one, get device. Right, you can see that I created a device with the respective scan group. Okay, so I'm going to just go straight to create a tag first. Right, and what I'm going to do instead of calling it right now, I'm going to use the UA client to browse again to show you what happens on the project on the TKE side right now. So you can see that now the Modbus channel has been created, a device has been created, and there are 2 tags, right? So I can actually add the add the whole thing over into the UA client, and you can see that my devices are pretty much created. We just remove the internal tags, so that's cleaner. And then if I launch the quick client now, right, you can see the 2 tags are created. So pretty much that's really the whole use case of the TKE. So in what we see, or rather the purpose of the whole TKEs was kind of to have a way for you to programmatically call it and patch it, through command lines rather than going down physically to kind of do something to it. So that's what we have for the TKE. Okay. Are there any questions? Maybe if there are, you can type into the Q&A. I'll just wait for 1 minute. Or rather, I'll wait for 10 seconds more. Okay, so without going too deep into other stuff, I will just quickly move on to the next section, which is the more IoT centric stuff, right? Okay, so for this section, right, I am going to talk about the how Kepware fits into, or how do we actually send out to various IT centric systems. Right, so this is a rough agenda of what we do, and we will again, do a few demos just to show you some of the capabilities of the IoT gateway. Right, so again, just to level set everybody, what really Industry 4.0 is, or IoT. So it's a term first coined by the German government, I believe, to describe a manufacturing digitization project. And what it really means, right, to most of us in OT is just the emergence of interconnected systems, and because of that connection, it is now possible to have what we call the convergence of physical and digital systems, or what in the market people call digital twin, right? And that really allows the emergence of new service and new business models for most of the companies out there who are rethinking of how they can generate revenue with all this technology out there. So if you're interested, feel free to go into the blog that we have that goes in depth on this topic. So the link is there. And what it really means on us for us, at least on the Kepware side of things, it just really means data, right? So we are actually still doing the same thing, just that now we have new stakeholders that we will send out, right? Everything is data. So for those who are familiar with the traditional OT stuff, especially people who are dealing with ISA 95, so this is pretty much what is some of the key difference between the old L0 to L4 systems compared to IoT. So again, we are taking raw data pretty much from the controller and sensors, and some of the assets, typically through OPC, and we grab it and then we send it out to the different platforms, right? So that's really kind of a disruptive move to from what we are used to. Last time we used to have like PLC sensors, and then we send it to SCADA, and then from SCADA we abstract it to maybe a MES, and then from MES we move to maybe a ERP system or things like that. That's the traditional way we deal with a lot of the manufacturing systems. But now, the IoT systems, they kind of want the raw data for advanced analytics and things like that. Right. So in a more architectural point of view, this is pretty much what most of us will end up with, right? We will have a lot of sensors and devices, and what we really want to do is to have something to connect to all of them, and then we send it out to the cloud, right? So that's really one of them. What the typical deployment architecture will look like, or you could have something straight on the cloud and do a direct connection to the devices, assuming that the devices are connected to the cloud system somehow, right? Of course, assuming the necessary security deployment are in place. You don't want to send like raw Modbus payload through the WAN. It doesn't make sense. So yeah, so things are coming up. And in order for us to do that, right, if you are familiar with Kepware, pretty much what we are doing with usually the OT stuff, we connect to the devices, right? We connect them in very easy manner. And now we have to send it out to the IT-centric system, right? And for the IT-centric system, I think it's much more organized. There's a couple of protocols that are pretty big. And for that, we have added them into the plugin called the IoT Gateway from Kepware. So what that really means is that if today you have a Kepware right now that is connected and sending it to your Wonderware, your SCADA, what it really means is that you could just buy the IoT plugin and immediately send that same data to the SCADA into the IoT platform that you want to, right? So things like a REST client. So for us, we have the REST client and REST server, which pretty much is the HTTP stuff. We have the MQTT client driver, MQTT agent, which allows you to publish data into a broker for the other consumers to consume in the topics. Last but not least, we have the ThemeWorks agent, which is designed for ThemeWorks, but we have already moved on to a native connection, so don't use that. And the common thing across the agents that we have is that we are using JSON as the message payload. So regardless of whether it's MQTT or REST, the standardized payload for the IoT gateway is the JSON format. So just as a brief background of what those are, the JSON payload, is actually a JavaScript object notation. I think for most of the developers or the IT side of things, this will be something that is second nature to them. How it looks like is that it has a curly bracket. So you can see that in the example below, we have the curly bracket stuff. So that's the curly bracket, and then you close the curly bracket. And then inside you can load what we call a key value pair. So a key value pair refers to things like the ID, which is the key, and the value is the string over here, right? So key value, key value, key value, key value. So the whole thing encapsulated in a curly bracket, and we call it the JSON payload. And in the IoT gateway, we allow you to actually configure the format. So there is a standard template that you can use, or you can use the advanced template to fit into other requirements that may be imposed to you by the third-party APIs. And then for the REST stuff, if you are not familiar, again, just a very brief background, what it means is a representational state transfer. And strictly speaking, it is not a protocol, it's just a framework, or a kind of communication framework where it is not connection oriented. So that's why it's called stateless, right? But what it means is that when you fire out the request, right, there will be no connection state tracking. Unlike your TCP, which there's a three-way shake on the socket, there is a connection awareness. But for HTTP, no, there's no There's no connection awareness. So really that's what the RESTful framework is. And in the, I guess in the IT world, right, the majority when people talk about REST, they are actually referring to HTTP. So that really is why we use the term RESTful interface and HTTP pretty interchangeably, right? But again, it's actually two different things. It's just that HTTP is one of the major protocol that uses the RESTful framework design. Then for the MQTT, pretty much is the message queue telemetry transport. So it's actually a very efficient and lightweight protocol to send messages out. And the biggest thing for this is I feel that is the scalability. It has a broker in between that allows you to have topics inside them. And then for your MQTT client, you can publish data to a single topic. So a topic looks like this typically, right? You can see this topic is called sensor/vibration, sensor/something/something. So that's pretty much the topic. So your agent can publish to the broker, and whoever is subscribed to that same topic receives the same message, right? And on top of that, they have the QoS service built in, which specifies the reliability of the message delivery. So that really is a very nice protocol for you to really scale up and send out data. And on the lower layer, it leverages the TCP/IP as well as the SSL version. There is also a WebSocket version, but that is not supported by Kepware today. So really, this is just another architectural point of view for what we have on the IoT gateway. And really, when we talk about IoT from the perspective of Kepware, what we really talk about is the sending of data to IoT platforms using the IoT plugin. Right. So a deployment scenario could be that you have a bunch of devices and then you connect it to all the drivers that we have. And then you have a cloud service, right? Then you can actually send the data out directly to the cloud, in a way that you can send from here to Kepware straight away to the cloud. Or you could be doing what we call the edge post-process data. So we take the data and someone on the edge side could be doing some processing on this and send out a limited set of data set into the cloud instead. So rather than sending everything out, sometimes the data are pretty useless. They zoom in on what is necessary and they post-process it so that we can actually have a feedback loop, on the edge side, and that allows them to have more IoT-centric deployment, more intelligent systems, right? Because if you wait for the cloud to come back to you, how long does it take? Especially using 3G, 4G. So I don't know. So we gotta be aware of this kind of latency issues. Okay, so I think my next section is going to be a demo, but before I get into that, I just want to make it known that we have a bunch of materials around the IoT gateway. The first link is the IoT gateway demo video, so it's a pretty straightforward demonstration. If you want to play with the IoT gateway, I recommend you to take a look at the Made Easy guide. And we also have an IoT webinar series, which is focused on use cases. I believe BMW and some of the other customers were sharing on how they are employing the IoT gateway. And we have a bunch of knowledge-based article as well with regards to the MQTT stuff. And last but not least, we have a very good manual. If you are keen, you can read the manual for the full-blown documentation of what are the capabilities of the IoT gateway. Okay, then on top of that, if you are a direct user of one of the cloud platforms, the guides are all out there. We have the Azure guide, which is what we're going to do later as well, and we have the AWS guide, and these are pretty much some of the major cloud vendors that we have encountered. So the first demo, right? Before I get into that, I just want to show you what I have. So again, if for those who are attending, from yesterday, I actually have a system configured right now, and these are actually configured to an actual system. So I have a Automation Direct device. I have a Mitsubishi, but it looks like it's not working. Never mind, that's okay. I have the mobile sensor, right, that is connected, and we'll talk about that later. And we have the TKE stuff, right, which is just connected just now, and then we have the Modbus stuff. So they are all actual systems, right? So just to to show you guys that Steve is not lying to you, I will enable my diagnostic, and then I can open the diagnostics. You can see that there's really TSRS going on. And for those who are familiar with Modbus, this is the Modbus common protocol function code, function code 3, broadcast ID 0. Oh, never mind. Let's not go over there. But anyway, yeah, we have something going on. What we want to demonstrate right now is the use of the IoT gateway. So I'm going to just minimize all this that are not so interesting right now. Okay, so I have a couple of stuff. I think we will first talk about the REST server, because that's the one that I feel is the easiest to understand. So when you right-click the IoT gateway, you actually can click new agent, and you can choose the type of agent that you want. So the REST client, REST server, and MQTT, right? So for now, we're going to do the REST server. So you can see that the REST server, pretty much, this is the server interface. You will choose the port that you want the server to be on. And once you've done that, right, you can actually click the hyperlink that appears. Okay, so when you see this is pretty much the documentation of the IoT REST server. So if you click browse call, right, the /browse, you will actually be able to see the JSON representation of the text that I have over here. So whatever I put it into the IoT gateway is being represented by a JSON format. And what that allows you to do is that we have a browse call, a read call, and a write call. So you can actually browse the system programmatically, right? And then do some form of read and write into the system. Okay, so a more advanced application could be that you could be building your own simple web page, right? And you can see that this is pretty much one page HTML with JavaScript, right? So the JavaScript is right here, and then that's the HTML section, which gives you the UI portion. So you can see that we can actually connect to the REST server interface, and we can actually see the data pretty easily using the REST call, right? For those who are in programming, it's pretty straightforward to implement a REST call. So that's pretty much one of the first use case of the IoT gateway, right? So the next one would be a Telegram demo, for example. So for example, you want to build some sort of chat client or chatbot, right? Let's take it as example. So what you can actually do is you can actually read the Telegram API and pretty much figure out what is the correct call for this and the correct method, right? So just do a quick one. Right? You can read through this documentation, and then you realize that it's actually pretty straightforward. So you just need to do a bunch of subscription, make a bunch of calls, get the token, authorize it, and when you're done, right, you add it to the REST client, for example. So what that happens is that you can actually then publish data directly into the what do you call that, the bot itself, right? And when what happens, you can see that is that now I have the text going on, right? You can see that actually they started to post all the different data, right? The values, the client counts, whatever you see here, right, is actually from this guy. So I call it the system info. So I'm just publishing the active contact number of clients into the bot, just as a representation, meaning that whatever you have in the capware, right, you can actually quickly reuse it to publish the data out. So let's take an example, the same device from the Modbus sensor. I can use that same device and I can throw all the data out, right? And then once I get it out, you can actually send it again. This is to the same endpoint. I'm just dumping and making another one to organize it a little bit. You can see all the data coming out right from here, right? The screen control is 0, the pressure is this, blah 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 blah. So you can also use it to do like advanced stuff. Because basically what we can do is that you can extract it somewhere and then post process and then send it out to the bots and things like that. Okay, so I'm going to just disable right now because if not, the whole chat box will be just flooding. So that's really the second use case of the Telegram, which I wanted to do a quick demonstration. And for the last demonstration, I'm going to do the MQTT one. So the MQTT client can be used to connect to Azure. So for those who are not familiar or wondering how did I do this, you can just type capware micro Azure, I think. Yeah, then just click this, the first link that comes up. Yeah, so this is the connectivity guide that we have, right? And if you look through, it's pretty much a very detailed documentation on how to do this. So if you go through it, you will be able to know like what to put in all these things. So I've already pre-created them. What I'm going to do is I'm going to just enable it, right? And actually once you see that once it's enabled, right, the data will actually flow into the MQTT platform and not to the MQTT broker and the Azure side of things. And you can actually start to see the message being sent out through the IoT Hub. See that? So again, just to show you, I can then dump other stuff into it. So imagine that today you already have something, created on Capware, it's as easy as configuring the IoT gateway and then sending out the respective messages into the platform and things like that. So you can see the Modbus data start to come in. Again, this is how the JSON looks like. This is the key, this is the value, key, value, key, value, key, value. And this is actually a very gigantic array, right, of how it looks like. Yeah, so that's pretty much the IoT gateway. The last one that I have is the InfluxDB, but I did not on my InfluxDB, so I'm going to just skip that demo, right? Yeah, so that's all I have for the IoT gateway right now. I will just take a quick look at the question box. So, ARM is not supported. Yes, somebody asked on the ARM stuff. Yes, but the ARM support is coming, just to let you know. Right. But if there's no question on the IoT gateway, I will quickly move on to the next section. Okay, I'll just wait for same thing, 10 seconds. How do you send to the influx? Oh, okay. So for influx, there is a line protocol. And pretty much what you do, right, is, let me just share my screen again. Right, if you Google the influx line protocol, I believe. See that? So this is the syntax. This is the sensor, this is the measurement, this is the text set, and that's the key value pair, right? So you look at this thing, right? So what we will do, right, in the influx side, or rather the Capware side, right, you will configure this with the endpoint. So before that, you got to create a DB, right? And then you do the post method. So what you want to do right now is to configure the template, right? So again, just now, when we see all this is the standard format, right? So if you look at this, that's the standard format. And if you go under the advanced template, right, you can actually customize how you want the payload to look like. So all you have to do is to match the payload to how the expected payload looks like. So in this case, it's really not a JSON format. So you can see it's totally not a JSON. You just add in the different key value in order to look similar to this. And if you read on our documentation, there is an advanced template, and you can see the different examples, right? So you can see that this is actually pretty similar to what you're seeing over here, right? So you can edit and change the format in order to match what the API asks of you. Yeah, I think somebody raised a hand. You can actually do a Q&A. If you don't mind, you can type a question into the Q&A panel, and then we will get to you. Okay, so it looks like I think there's no more questions right now. So no, but along the way, feel free to continue to type in. we will get back to you, right? If not, I will just hand over to our guest speaker, Kaijit, for the next section from the Omron stuff.
Hello, can you hear?
Yeah, can.
Yes, we can hear you. Yes.
Okay,
Thank
thank
you.
you. Thank you. Can you see my screen?
Yes.
Okay, so I'm running in the presentation mode. You can see now?
Yes, we can see that.
Okay,
Thank
okay.
you.
Thank you. Okay, so good morning, everybody. I'm Gaiki from Omron. Together today with me is also Lloyd. He will support me on the demonstration later. So today, thank you for the invitation from Catware. So thank you very much. We have this chance to opportunity to also explain our solution that we have actually worked with Catware on the IoT solution. And today, one of the important solution that we wanted to present is on the IoT solution on the predictive maintenance. Okay, so without ado, let me start on the explanation. Okay, so very quickly, I will just want to explain what is actually predictive maintenance. So as a term of a predictive, we wanted to able to predict the maintenance that will happen in the machine or in the factory floor or even the facility before some event or situation which actually happen and eventually have some sudden what we call the sudden stop of the machine or even the facility itself. So these are very important, and especially nowadays when we have a lot of remote maintenance and remote management from different areas and even from different countries. Based, for example, like the mother or HQ in Japan to Singapore or Malaysia factories. And this whole predictive maintenance, one of the most important thing is to collect the real-time data to identify the current status, the progress, and also situation in the machine and also in the factory floor. So why predictive maintenance is becoming more and more important? It's not just because the machine will just break down, but when it will break down. And if we can predict or to call estimate the time it will actually break down, and we can do the maintenance before it happens, it will actually help to save a lot of not only time and also money for the companies. And these are addressing, I think, I believe almost all companies have this kind of situation. So one of the, I think, most important industry that is actually facing this issue will be mainly this in the semicon, where a very sudden stop or failure or breakdown of a certain component or even on the facility itself, for example, power supply or the panel itself, can cause millions of dollar loss for the company. And today we have a lot of situation where we are actually calling out the new norm because of the COVID-19 pandemic situation all around the world globally, and also especially in the Southeast Asia environment. So what happened is that there is a very major or a lot of labor shortage because now people can't travel around, and when especially countries will require a lot of overseas operators or laborers, that if this even causing more serious problem for them. And even though the factory can operate, they have to keep a safe distancing between each operator. So that means what does it mean is that last time, for example, they could actually have 100% or 1,000 operators. Today, they could maybe only have 800 of them. That means they have actually reduced almost 20% of their labor to operate or to try to achieve the same production. That is actually very tough. And one of the most important thing, of course, is automation, and that will help them to speed up and actually enhance the capability of this productivity with less labor. And that is when more machine and more devices coming in, the importance of predictive maintenance become even more. And that's where IoT becomes very important. And that's where data collection, the monitoring, and also in the analysis of the data is becoming more and more important. So rather than the operation of the machine or the production floor itself, also there's a lot of factories require labor or people to actually go down to the factory floor and to check on the machine status or even on the process status in a periodic situation. And with current labor shortage, we need to companies want to put all the resources in the production itself rather than doing all these maintenance check operations. But this point is also still very important. So that's why a lot of customers and also companies wanted to convert these labor checks into automated checks by system and also by IoT capability. And one of the reasons why there's still a lot of labor to do all this checking is because the machine itself is very complicated. You can't just based on the looking at the data and you know what is going to happen. But this kind of situation is become even more important. So companies can no longer rely on labor, and we need to get as much of data as possible, and also use this data efficiently to actually detect the maintenance or the status of the products itself or the components. So the main objective is actually not only to do the scheduled replacement of these components, but to do maintenance before the component is detected to fail. Okay, so of course the solution that we're looking at will be the predictive maintenance. So for example, in the factory floor, what kind of things do we want to monitor? And actually, who should be monitoring it? For example, the typical things that we know, like what Steve has actually mentioned, for example, like PLCs, sensors, vision cameras, monitors, safety devices. These are a lot of I think, especially in the digital industry, a lot of customers or companies has already been monitoring, connecting data from these devices daily, every minute, and constantly monitoring this. But there are also a lot of other things that require the people to actually not monitor. For example, the power supply. Power supply today is just a component and connected to provide power to the devices. But nobody is actually looking at the predictive or when it will detect to fail. And another area, for example, will be the motor itself. As today, we have a lot of getting more and more complicated machines. Motors, as I think you will know, that is actually getting increasing in the factory floor. And with the additional motors and also in the equipment of the facilities, for example, HVAC has uses so much motors that the monitoring or the breakdown of this motor will cause a lot of issue for the companies. So these are the critical components we also need to monitor. And today, a lot of this importance actually being placed on the panel itself. If the panels heat start to increase because of the increased demand of the operation of the devices, sometimes the heat or the improper airflow causes heat increase in the panel. And over time, it even cause fire and cause the breakdown or even small property damage or asset damage or even machine damages. And today, the panel monitoring becomes so important, especially in the thermal condition area. Okay, so just highlighting all these areas that I have mentioned along. Okay, so just quickly, just how HVAC is important. So especially in the, it's actually used to do the heating, ventilation, and monitoring. And especially in the semicon or the other digital industries, clean room is actually very critical point where they need to maintain the quality of the product. And it's not just for the comfort of the workers, of course. It's actually to maintain the environmental condition for the high efficiency quality of the product. And these are many parameters they need to monitor in these days. And we did a certain kind of survey with a lot of a number of customers, and we understand that there's a lot of critical components or assets that we needed to monitor. For example, cooling pump, gear switch, power distribution, gearboxes, conveyors. And a lot of these causes are mainly coming from wear and tear, misalignment, temperature, increased changes of temperature, contamination, pressure, and things like that. Now, so Omron actually looking at this area, we wanted to help the customer to be able to predict the situation that will occur, and we come up with these predictive maintenance solutions. Okay, so what are these solutions? So basically, we collect the information of the components, we monitor the condition of the components, and these are actually monitored on site. But we need to collect this information to a centralized area so that we can show or monitor or actually present it or virtualize it in the system, and also to contact the relevant departments or person to do or prepare the maintenance, or even prepare the component purchase before it actually break down. So this is a configuration example, typical configuration example we have for the customers that we have done basically with these components that I have mentioned earlier. So for example, here what you see is actually a PLC where we actually, for example, still there are a lot of customers, they are still using a lot of components that do not have network capabilities in the existing factory floor. This is actually very typical in the Southeast Asia area, and we still need to monitor the conditions and situation or progress or status of these devices. And so one of the communication network we can use will be the 485, where you can connect to the our PLC and collect this information to a centralized controller. With the OPC-UA, we can connect to the CADware, and we can virtualize all these status and monitor into one whole centralized area. Okay, so another area that we can actualize in terms of the protocol will be the Ethernet IP or Modbus to collect all this information, especially on the thermal and also motor condition area. And in addition, you can also monitor the power supply condition into this same database, same area by OPC-UA, where CADware can convert these protocols and the conditions back to the either centralized database or the cloud, where we can actually virtualize all this information. Okay, so one of the advantage Omron wanted to provide for the customers will be the easy setup, especially with the CADware. So later, my colleague Lloyd will show you how it's actually being done. So this is the software where the Switchback Studio development tool for our controllers, where you just need to define the variables that you want to monitor, which is collected directly through the devices by Ethernet IP, and you can map this to the CADware easily, and you can monitor this information very easily on your virtualization tool or other software. Okay, so just very quickly, what kind of areas that we actually can monitor, or what kind of parameters we can monitor. So for example, the display of the local display of the motor condition, and the alarm functions. And for example, in the motor, we can actually monitor the overload conditions, the bearing, the insulation breakdown that we can monitor using the K6CM. And with the IoT ready power supply XVK-X, we can have a 24-hour monitoring. Basically, the power supply itself has a communication of Ethernet IP or Modbus that allows you to monitor the status, the power consumption, the current output through this communication, and you can collect all this information no matter how many that you have, for example, 100 or 200 power supplies that you're using in the factory floor, and virtualize all these situation into your system. Okay, motor condition monitoring, for example, this one we will demonstrate later in our by Lloyd later. We can also do the same for our motors and monitoring the condition of either the breakdown of the bearing or the vibration issues that's actually causing a lot of issue for the motor. So by monitoring this condition, we can actually prepare to replace the motor before it actually breaks. Okay, so this is what I mentioned earlier on the panel itself. So through this panel monitoring, we can which is the sensor which is mounted onto the panel. For example, you can monitor which area within the panel that is actually having higher heat, and the heat itself is actually achieving certain threshold. For example, the normal condition of the panel should be around 45 degrees, but it's actually exceeding 45 degrees. Then the alarm will be sent out through the network, and we can actually monitor which panel, which area, and which panel is having this situation, and we can actually do something before it have fire break out. Okay, so that's all for my presentation. Thank you very much. So next, I'll pass on to Lloyd to do the live demo. Lloyd?
Hi, I'm Lloyd from Omron. So now we shall share screen on the demo setup. Hi, you all can see the screen, right? Okay, so without further ado, so actually today we will demonstrate on this particular setup that we have on the demo kit. So what happens is that we will have this NX102, what that Kai had mentioned. We will actually collect the data from both of these two units, the K6CM, which is the motor conditioning monitoring, and the SAPK power supply monitoring to go back to the NX102, and then we will pass the data to CAPware, which is now currently installed on my computer. Then thereafter, we will actually use the CAPware to send data to maybe like what Steve had mentioned, done previously, the Telegram. So currently the setting for the K6CM for the degradation level is actually warning at 15, and then above 30 will be critical. So later we along the way we would I will explain the degradation level. All right. So let me on the D-Link connectivity of the live cam. Yeah. So currently, as you can see, this is actually the setup that we have here. So this is actually the warning light, and then this is the critical light. This is K6CM module, the NX102, the power supply, and then there's a motor running inside. So currently the degradation level is actually at 7, which is a value that we allow user to understand rather than having all the different kind of readings to simplify all the processes. All right. So now we will go to the Sysmex Studio, which is our online platform for programming. So as you can see, this is the power that I actually drag out for you all can see. Let me size down so that you can see that together with the module here. All right. So so as you can see, the 9 value, this is the degradation which is actually shown here, but I think there's an update not so fast. Then the other one, the display will be the current amperage running, which is 1.5, but we did not have the decimal place, we actually put it in. And then of course this is the voltage for this power supply and the current. All right, and then this is actually the warning, and this will be the critical value here on these two lights. So what happens is that when now you can see that it's true, means that it's actually running in a good status. So when there is a warning, right, what's going to happen is that the warning status here, right, will actually turn to false. This is actually a reverse kind of logics to trigger some of the alarm system locally, which we can actually connect through here. All right, the physical wiring over here. Okay. Okay, so let me just go to the CAPware side. We actually have 2 sets of connections. One is the OPC UA and one is the direct. So OPCUA, you can actually import the tag and select through as what Steve has shown earlier on over here. You can just drag and drop, but we already have done so. So I will not move to, I'm gonna go towards there. So these are all the details. All right, then for Annex, the other one is that Careware actually has developed a very good software tag generation for Omron. I think it's a co-creation. So what happens is that we can actually easily import the text immediately, and whatever that's inside the PLC, you actually just put it in when we are creating the tag. So I can see tag generation, tag number created is 103, and then everything is put under this particular guy here. These are all the tagging. All right. So now we will go to the quick client and compare the value against the Sysmex Studio. So we will still go back to the same thing, which is the one that we want to key concern about, which is this guy, the one that's monitoring the predictive of the motor. So this is the warning NX1, the input bit 00 and then 01. As I mentioned that the warning is actually set at 15 and then critical is at 30, right? So when I trigger the screen, when I trigger this video here, you will see that the light of when this thing turns off, right? This one will actually turn to false. So this just to show that the quick client actually monitoring, we are routing through everything from the Sysmex Studio, which is the actual value, then with quick client through the OPCUA, which is this one, and then yeah. So let me just demonstrate the warning portion. So let's try to. So what I'm going to do here is that I'm actually pushing a rubber inside this lever here. Let me just show. So this lever here will actually create some forces to the motor shaft. So by doing so, you can see that the value has gone up to 18, and then the green light is actually turned off, and the warning value has turned off, and then here the value is turned off. Reason being that we have detected that the motor is actually in a warning critical warning condition. So let's say if I actually push even harder, when it goes above 30, you see that you will notice that the red light here will actually turn off, which is actually a critical state. And at the same time, you will see that we will push the data to the OPC on the Careware side through OPCUA. So this demonstration here is to demonstrate on the so-called the IoT predictive monitoring of K6CM, and then we aggregate the data through NX102, and then simply port this data through OPCUA connectivity to Careware. All right. So now I will pass the mic to Steve to show you that the all this data is actually port through the OPCUA to Careware. So he will use his laptop to tunnel to my laptop through OPCUA again, and then pass it up to Telegram. All right.
Okay. Hey, thanks, Lloyd.
Yep. Okay.
Yep. Okay, so I'm going to just share screen. So again, back to the same screen. And what we have, again, we have a UA connection, right, to the NX 102. So again, it's simply the IP address and then the port number, and then we get to the Careware on the other side. And then what we'll do is that we can actually browse the PLC. So you can see that the setup, right, is pretty clean, in the sense that you can see what the PLC has, and the data are more meaningful, right? As opposed to the traditional kind of PLC where you only have the I/O addresses. Instead of that, is now the data in the new generation of PLC, such as Omron's NX, is pretty much way more richer. You can see that the data model is built into the PLC itself. So you can actually use that to actually look at what what we have. So again, we just need to pull out the same 2 bits that just now Lloyd has shown, the warning and the critical part, right? So just need to add it, and then you click OK, click apply, and then the text will just flow in, right? So you can see that the texts are these 2. So what I'm going to do now is I'm actually going to do the same Telegram stuff to demonstrate the concept, right? So once you get it connected to Capware, right? Let's just show you right now. You can actually see the 2 tags that we are talking about, these 2. Right, so the tag that you remember, the LED changing color above the threshold 15 and 30 is actually governed by these 2. So what we can actually do, right, is to put that tag into the IoT gateway, and we can use it as a simple notification system, right? So now if I go back to the Telegram, right, you can see that the data is is coming in. So now it's at true 11. Yeah. So now what we're going to do is we're going to try to just trigger so we're going to try to just trigger it to just show you how it looks like. So now actually the actual system is now at above 15. So you can see the warning has started, and then what will happen is that data will then be pushed into you can see that now it's all false, and both at warning and critical. So you can use it, using Capware, you can use it to build a simple notification system. And similarly, the same tag can again be reused to send to Azure. Maybe you want to build a time series database. Maybe you just want to make a REST server. So there's a lot of possibilities once you have a platform like Capware to connect them, and you have like this kind of next gen PLC. There's a lot of stuff that you can do. Yeah, so with that, I think we have